My name is Uncle Sabarko, and this is my demo for the programming project for COT 605 analysis of algorithms. In this project, I implemented and compared two algorithms to solve the closest pair of points problem, brute force and divide and conquer. As you can see here is my Python code. I implemented the brute force method, which checks all the possible pairs of points. The algorithm has time complexity of theta of n squared, meaning its runtime grows very rapidly as the number of points increase. I also implemented the divide and conquer method, which is a recursive strategy and achieves a time complexity of theta of n log n, which makes it more efficient for the large data set. Yeah, there you go. And for the experiments, I generated random distinct points and tested input sizes ranging from 10,000 to 55,000, increasing in increments of 5,000. Each input size was tested over 10 iterations, and I recorded the average runtime for both algorithms. Since the brute force algorithm can take very long time for large inputs due to its theta of n squared growth, I ran the experiments on Kaggle kernel. This allowed me to avoid session timeouts and ensure a stable and uninterrupted runtime environment. After completing the experiments, I saved the results into two CSV files, which are here, as you can see. Here you can see the tables generated from the data. Each table shows the input size, the empirical runtime, the theoretical runtime, and the predicted runtime based on fitted constants, and the ratio between empirical and predicted times. And you can also see the graphs created for the experimental results. The first graph shows the empirical runtime comparison between brute force and divide and conquer. As expected, brute force grows extremely fast due to its quadratic nature, while the divide and conquer maintains much more manageable growth curve. The next two graphs show the empirical versus predicted runtimes for each algorithm individually, confirming that the experimental results closely match the theoretical expectations. There you go. In conclusion, the project successfully demonstrates the theoretical and empirical behavior of both algorithms. The brute force method becomes impractical for large datasets, while the divide and conquer method remains efficient as input size increases. Overall, both implementations and the experimental validation were successful. Thank you for watching.